So we would like to calculate this volume integral where E is the region that is enclosed by the planes z equals 0, z equals x plus 5 plus y, and by these two cylinders. So I think first it's a good idea to go ahead and graph it. So we go ahead with this implicit graphing feature of MATLAB to graph the surfaces. We are just going to keep z equals 0 open to be able to see. So now we are going to just say Control Enter and a graph should appear. All right. And now for a better view of graph, I generally take it to the figure window. Okay, so just press on it. So now we have this view of the graph, and you can see on the lower side it is bounded by the z equals 0 axis as was given. I did not graph that just to get a view, and the walls are the cylinders and the top side is the plane. So as I said, the bottom is this plane, z equals 0, right? And the outer wall is x square plus y square equals 9. And the inner one is, as you can read right here, x square plus y square plus, x square plus y square equals 4. And this is z equals x plus y plus 5. So using cylindrical coordinates is a good idea here. So when we transform, what we shall do is that we shall just write a triple integral. So first let's just go from this value from 0 to z, and now on the bottom it's going to be enclosed by this region, right, for the r theta range. So r will vary from where to where? The radius here is 2, radius here is 3. So r will go from 2 to 3. And since it's going in the entire circle, that would range from 0 to 2 pi, right? And then what we have is, then we have x. What is x? X is r cosine theta in cylindrical coordinates, right? And then we will get r sine phi. Just a second, I'm going outside of the recording area. So let me just write it here. Okay, so we have 0 to 2 pi. Okay, 2 to 3, 0 to z. Then x is r cosine theta. So we got r cosine theta. And then we will have r dr. First we have dz because z is first, then dr d theta. All right. And now we just have to evaluate this integral. So we are calculating this integral, and z is x plus y plus 5, right? And so we will write x plus y plus 5, or in other words, we may just put in here r cosine theta, then r sine theta plus 5. All right. So first we are integrating with respect to z, and when we do that, this whole quantity will be treated as a constant. And let me remove this and make this into a square. Okay, so when we do that, what shall we get? We shall get, here we are, the first two integrals, and integral of dz will be z only. So what we have is that we got z with an upper limit of how much? With an upper limit of this, okay, and lower limit of 0, right? So which will keep things easy, and then we got what? Simply dr d theta. So right here, and then what this will become is, or what the quantity to be evaluated will become is that we have this, right? And then we got r cosine theta plus r sine theta plus 5, right? And then we simply got, and I forgot my r square cosine theta, I'm so sorry. Let me just put that back in here. So then we have, yeah, this right here. So we got this, and then r square cosine square theta d theta, right? And now we can just go ahead and compute this as a routine double integral, okay? And if you want, I can show you these steps later, okay? And the answer is going to be 65 pi over 4, okay?